All right, so we're looking at homework 1.2. Homework 1.2. So do h and k affect the input or the output for g of x equals f of x plus k and g of x equals f of x minus h? So you're supposed to explain this via shift. So if you look at f of x plus k, the k means shift up or down. Now, that is affecting y, which is the output of a graph function. Now let's look at f of x minus h. Okay, h shifts the graph right or left. And again, it's opposite of the sign. And that means we're affecting x, which is the input. All right, moving past that, we're supposed to do some graphing here. It says graph each function given and its parent function on the same graph. Label the parent function f of x and child g of x. All right, so this is kind of old school review here. Here, f of x would be mama, and if this is a square, mama is going to be x squared. I haven't graded all the mother function quizzes that I gave today, but we'll see how they go. Mama contains 0, 0, 1, 1, and negative 1, 1. And I'm just going to label it f of x. The child, remember this guy? This is not right 3. This is not left 3. That's right 3. And this guy is up 4. So I can go right 3 and rise 4. It'll be about right there. And the child still has an understood slope of 1. So it's going to rise 1 and run 1 both ways. And there's g of x. None of this is too terribly hard. I don't know why, but number 4 is just going to blow kids' minds. It's going to be number 4. And number 4 is the one you've been doing since you were in middle school, right? Like g of x is negative x plus 3. Well, mama is simply f of x equals x, or y equals x. Maybe you need to think of it like that. Not trying to use function notation to throw you off. It's just that's what function notation is. Anyways, mama contains 0, 0, 1, 1, negative 1, negative 1. Mama is a straight line. So here it is, mama f of x. The kid is literally in the form mx plus b. Rise 3, slope is negative 1. Fall 1, run 1. Fall 1, run 1. And there's the kid, g of x. Let me make sure there was nothing else the instruction said. It just says graph them on the same graph, label the parent f of x, child g of x. So yeah, golden. All right, moving forward, let's look at number 7. Describe and correct the error a student made in graphing g of x equals f of negative x as a reflection across the y-axis. And they did make a huge mistake because they did not reflect on the y-axis. Obviously, the student, and we're supposed to describe, so under describe, we can say the student reflected over the x-axis. There's their mistake. Describe the mistake. Obviously, now we're supposed to fix this. So the rule about forming a y-axis reflection is pretty simple. The rule is given, and the kid didn't do that. We're going to pick out some key points on this graph here. I see the point negative 2, 1. I see the point 0, 3. And I also see the point negative 4, 3. So I'm going to go ahead and copy those points down real quick. But there was a negative 4, 3. There was a negative 2, 1. And then there was a 0, 3. And the rule on these is just change the sign on x. So 0, 3, it still becomes 0, 3. It doesn't go anywhere. Negative 2, 1 becomes positive 2, 1. We just change the sign on x. And then negative 4, 3 becomes positive 4, 3. And then those are the points we plot. So right 4 rise 3 is now a point. Did not mean to do my highlighter there, sorry about that. Right 4 rise 3, right 2 rise 1, 0, 3. This is what the thing should look like. It says describe and correct, right? So make sure you correct. All right, what do we got going on here? Graph each function as a transformation of its parent function, state the domain and the range. So it turns out that even though these have the full form with a, b, h, and k, and they are in that form, we have an a, we have a b, we have x minus h, we have plus k. You can always eliminate b. That's one of the cool things about b. Anyways, we're supposed to graph each function's transformation of its parent function. So let's talk about mama first. Mama is y equals x cubed. Mama contains 0, 0, 1, 1, and negative 1, 1. And she looks something like that. And we're going to modify the crap out of this thing. We're going to use that distributive property of exponents. So we have 8 times a half that gets cubed times an x minus a 3 that gets cubed that we won't do anything with because it's exactly the way we want it to be. And then plus 3. And now in that blank space in our head, we write out a half times a half times a half, and we get that's an eighth. I've already got an 8 out front, and I'll have to clean that up a little bit more. But an eighth of 8 is an understood 1. And now I have A, H, and K. So I can take something that has all 4 letters of the full form, and by using a little reasoning, I can actually get down to 3 letters, which is easier to graph. And that's kind of the way I teach it. Make it simple. So let's plot this guy. It has a center at 3, 3. It still has a slope of 1, turns out, because what happened is this right here, because of its location, it actually made it 8 times as wide. It seems weird I'm saying that it's a half, but it made it 8 times as wide because of the cubing. And then you have this guy, which made it 8 times as tall, so it ends up being the exact same slope. It's kind of interesting how that works. Anyways, the slope is still to rise 1 and run 1. So I've got to rise 1 and run 1 right, and I got to fall 1 and run 1 left. Then I just kind of redraw mama, and I'm game, right? The domain of my function here, the child, the black one having black, is negative to infinity, and its range is also negative infinity to positive infinity. Let's see here. Let's take a look at 10, because 10 requires some factoring. Mama, of course, would be the absolute value of x. 0, 0. I wonder why that got so far off. 0, 0, 1, 1, and then negative 1, positive 1. There's mama. To do the kid, the first thing you have to do is pull that 4 out. We already had a negative symbol. 4 times x is 4x. 4 times 2 is 8. And the kid has a vertex at left 2, down 3. And then the kid has a slope of negative 4, so I got to fall 1, 2, 3, 4, and run both ways 1 unit. Got into my domain and range there. Sorry about that. But the domain of this orange function here is negative beta infinity because it runs left forever and runs right forever. And the range of the orange function is it falls forever and then rises to a maximum value of negative 3 with a bracket. Moving forward, last one I'm going to do for you. Below is the graph of f of x. Using concepts of transformations, graph 1/2 f of negative 2 times x minus 1 and then plus 2. And it says do one thing at a time and remember the order B, H, A, K. So the first thing I'm going to do is I'm going to put the letters where they belong. A, B, H, K. Now, B is actually negative 2. What this means is it means 2 things have happened, all right? For one is we have horizontally compressed. With a factor of a half. And because it's negative, we've also made every x b negative x. And so lots of things have happened here. So let's take this point right here. This point is at -4, -4. It is going to become 2, 2. Sorry, 2, -2. I don't change y, I just change sign on x. I've got a point right here that is at 2, -4. And it's going to become -1. That shouldn't be a 2. Forgive me, I'm off. That's still -4. You horizontally compress it. So I'm going to take half of 2 and get 1, and I'm going to change the sign and make it -1. This is -1, -4. So this guy became 2, -4, and this guy becomes -1, -4. All right, there's a nice point right here. It is at 4, -2. Half of 4 is 2, change the sign, you're negative. Now we're at 2, -2. Right there. Pause this real quick. I did not plot that point right there correctly. -1, -4 should be right here. Because I didn't see my slanty line, it threw me off. So I think about what I'm doing right here. Now, this point up here exists at 4, 2. You do your little transformation. I'm just gonna stop. I'm gonna restart this problem and go back and delete here. I have messed this thing all up. I'm sorry, but it's trashed. But anyways, let's see where I'm at. I'm at number 12 now. This thing is given in the full form with all 4 letters. It's got A is a half. It has B, which is actually -2. It has H, which is 1, and it has K, which is 2. Now what we're going to do is we're going to pick some points out on this graph. This is -4, -4. Now we're going to work with these points exclusively. It's going to become something as we do each transformation. This is 2, -4. This guy right here is 4, -2. This guy right here is going to be 4, 2. And then we got this guy all the way over here who is at 8, 4. And we're going to play with these points. Now the first thing we're going to do is we're going to handle this B being -2. What does that mean? All right, that means 2 things. We multiply x by -1, and we cut it in half. Because it's inside, we do opposite of what it says. It doesn't say double it, it actually says cut it in half. That's weird. When there's a whole number inside and it's B, it's actually about compression, not stretching. So you're horizontally compressing. So that's kind of weird. I get that. So 4, -4, we cut it in half, we change the sign, becomes 2, 4. Oh, I hate the highlighter. There we go. 2, 4. 2, -4 becomes -1, -4, because you cut it in half, change the sign. This becomes -2, 2. This becomes -2, 2. That should be -2 still. And this becomes -4, 4. All right, so lots of fun stuff on here. One of my new points is now at, and that's a -2, -4. It's going to be moved right here. -1, -4. Back 1, fall 4. I should be drawing a slanty next. -2, -2. -2, +2. and then negative 4, 4. Hopefully you can kind of see what we just did there is we reflected it because b was negative, and we cut it in half. All right, the order here that we're doing, again, is BHAK. So the next thing I'm going to do is I'm going to apply H, and H is the horizontal shift. That's what she is. So H is 1. We're going to shift right 1, and we do that by adding 1 to X. So this point that I have now at 2, negative 4, it becomes 3, negative 4. The point that I have at negative 1, negative 4, we add 1 to X, it becomes 0, negative 4. The point that I have at negative 2, 2, negative 2, becomes negative 1, negative 2. The point that I have at negative 2, 2 becomes, we add 1, negative 1, 2. And then finally, even though there's 2 more letters to talk about here, the point that I have at negative 4, 4 becomes negative 3, 4 because we are adding 1 to X. It's just a piece by piece thing. It's tedious. No, I get that. Go through and plot my points. I'll do a different color here. 3, negative 4 exists now. It's going to put me right there. 0, negative 4 right there. And all we're doing is we're shifting these things right 1 unit. That's all you're doing. I'm just showing you all the boring stuff in between, because I don't want to make a mistake. All right. No, 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 no. What have I done? Moved the wrong thing there. Let's undo that. I need more room. Just give me a moment. So far, what I have done is I have looked at B, I have looked at H, and now I have A. And A is a half. That literally means cut Y in half. So I'm going to take all these Y values and cut them in half. Instead of 3, negative 4, 3, negative 2. Instead of 0, negative 4, 0, negative 2. Instead of negative 1, negative 2, negative 1, negative 1. Instead of negative 1, 2, negative 1, 1. Instead of negative 3, 4, negative 3, 2. Good times, right? Let's choose red this time. 3, negative 2 exists. Should be about right here. 0, negative 2. And I put 3, negative 2 in the wrong spot. No, off. Sorry. 0, negative 2 would be right here. Lost my place. Sorry, kids. Negative 1, negative 1. Back 1, fall 1. Be right there. Negative 1, 1. And then negative 3, 2. Those lines should be touching each other. I didn't do a good job on the yellow line. Sorry. And finally, I'm at K. K is 2. That means shift up 2. So that means I add 2 to Y. So 3, negative 2 becomes 3, 0. 0, negative 2 becomes 0, 0. Negative 1, negative 1 becomes negative 1, 1, because I'm adding 2 to Y. Negative 1, 1 becomes negative 1, 3. And negative 3, 2 becomes negative 3, 4. Ah, almost done. Let's do this in purple. So now I have the point 3, 0 because I shifted up 2. I have the point 0, 0 because I shifted up 2. This guy is going to go right here. And this guy is going to go up 2 units from 1 to 3. Should be right there. And this guy goes up 2 units from 2 to 4. There is the final transformation. That is a really ugly thing. That's how most kids feel about this. It's not easy for kids to do. It's not. I get that. There's a lot of mistakes that can be made. It's easy to make a mistake, and you just end up with something hideous, which is how kids feel about this. And that is a very ugly piece of art. Maybe when I'm long gone and dead, it'll be worth something. It's not worth anything right now, though, is it? Anyways, there's what I got. Hope you enjoyed. Probably didn't. Anyways, see you tomorrow.